this line I've drawn is a 30 degrees line. Okay. So this is rotated from Y in a clockwise direction 30 degrees. Okay. So we are going to find or construct the element orientated or tilted or rotate 30 degrees clockwise from the horizontal axis. Okay, so we're going to do that. So I'm going to use the same circle, right? Because I did not change the stress field. I'm going to copy the same circle. So the circle size is still the same. Okay. So I'm going to copy the circle. Come over here. I'm going to put here. I'm going to paste. And I'm going to move this. Okay. So it is tilted 30 degrees from the horizontal. Okay. From Y. So I'm going to call this point, this plane over here. Okay. I'm going to call this our Y30 now. Okay. Because we rotated from Y. Okay. So on most on element, in element domain, yeah, right, slightly over in element domain. Oh, come on. So in element domain, is 30 degrees clockwise. Mohr circle is what? 60 degrees clockwise. Okay. So from point Y, not from the horizontal axis on Mohr circle, from point Y. Okay. So from point Y, we will rotate. So we'll rotate 60 degrees from point Y. So this is where it is. Okay. So 60 degrees. Hold on. Let me draw. Get a marker. Okay. So 60 degrees is here. I'm just eyeballing, okay, with a protractor. Yeah. So what I've drawn is from point Y. Now we rotate in a clockwise direction, and this is 60 degrees. Okay. So this point down here will be our Y30 point. Okay. And directly opposite will be our X30. Okay, Y30. So what we want to find now is we like to find our stress Y, normal stress Y30 position, and a shear Y30 position over here. And we are going to find our normal stress X30, and then our shear X30. Okay. Right. So before we go on, we have to find an angle over here. I'm going to use a different color so it's easier for you to see. We are going to find the angle over here, which is our beta angle, right? Why we need our beta angle, then it's easier to find stress Y30 and shear Y30. Okay, so we know that beta, right? We know that beta is equal to 60 minus by 45, and this is equal to 15 degrees, right? 45 because this is our 2 theta p, which we have found out already, right? So it's 15 degrees. Okay, and then from here, the first thing I want you all to do is it's a good practice. Okay, then you will not be confused. We want to find what is our shear Y30, which is also equal to our shear X30. Okay, and this is equal, so the radius, so we calculated the radius of the circle out tau max, right? So the radius of the circle is equal to 42.426. So this is 42.426, and then it's going to be sine 30. Oh, sorry, sine 15. Okay, so some of you might ask me why that is the case. So if I draw a horizontal line over here, right? And hold on. If I were to construct a horizontal line over here, and then this distance from the axis over here, so this is equal to 42.426 sine 15 degrees, right? So the shear stress sine 15 times by 42.426 is equal to 10.98 megapascal. Let me do it again. 42.426 times by sine 15 is 10.91. Okay, so that's normal stress. So the next thing that we're going to find out is the normal stress. Sorry, that the one we find is the shear stress. So the normal stress for stress Y30. So the stress Y30 we're going to find, it is from this point over here, right? And where we are going to get that value is from the stress average line. Okay, it's not from the zero line, it's from the stress average line, because at the center is how we rotate from Y to Y30, right? So we know that this will be equal to minus 10. It's going towards the right hand side plus 42.426. Now it becomes what? Cos 15, right? Because we have used up the sine already, so it cannot be the same sign. It has to be cos, right? So stress Y30 will be equal to minus 10, right? So because the stress average is on the left hand side of Y30, you have to plus 42.426 cos 50. Okay, so it's minus 10 plus by cos 15 times by 42.426, 40.98. So this is equal to minus 10 plus by 40.98 is equal to 30.98. And let me do it. 42.426 cos 15, 40.98. Okay, so now we also can find normal stress X30 is equal to minus 10 now minus 40.98. So then 40.6 minus 50.98. Okay. Now we have to construct our element now. Okay. Now this one is a bit not difficult, just getting used to it. Now we have a shear to be associated with the element now. Okay. So our original axis, okay, so this is x, and this is our y, and we are going to rotate this 30 degrees, okay, because the question says 30 degrees. Okay, so this is our 30 degrees. Okay, and then now we are going to construct our element rotated at 30 degrees. Okay, so we're now, so the angle that we just drawn, this is 30 degrees, and then we just draw the element here. Okay, and then like what I've taught before, same thing over here. This is our point Y, and over here this is our point X, right? And this surface over here, right, this surface over here, we know that it's our Y30 surface. Okay, so our Y30, the normal stress is easy, right? So Y30, you have a normal stress going out this way. Okay, the normal stress is easy because you guys, we have done the principal stress, it's the same thing. So normal stress is coming out this way, it's 30.98 megapascal. And then at the other end is your X30, right? So your X30 is going by compression, and this is going at 50.98 megapascal. Okay, so this is your megapascal. Now, the shear is a critical one. Okay, so give me 2 more minutes. Focus with me. Okay, we're almost done. If we look at Y30, right, which is our Y30 over here, the element has to rotate what? Anti-clockwise, right? So for anti-clockwise, the shear stress has to push it upwards to rotate what? To rotate anti-clockwise. Can you see that? Okay. I'll do it again on X30. Okay. So we know that this surface over here, right, is our X30 point. Okay. So X30, if you look at the rotation of the element, right, it has to be in a what? Clockwise direction. For it to be clockwise direction, the shear has to do what? Come down for it to induce a what? Clockwise rotation. So this value in terms of shear is, okay, in terms of shear is 10.981 megapascal. So the difference between this example and the principal plane one is you have what? You have shearing stress. Okay. Now, some of you will say, Eugene, can we rotate it from X? Can we rotate this orientation from X? Right? Yes, you can. The answer will be the same. So if from X you rotate this way, right? This will be what? X what? 60. Yes or no? Right? So X60 from X, right? From here to here, you rotate in a what? Anti-clockwise direction. This is 120 degrees. The answer will be the what? The same. Okay, the answer. So you can rotate from your X or from point Y. The answer is the same. The only thing is you have to compensate for the 30 and the 60. Okay, okay, that's all I have for today. Okay, now on Thursday it will be a revision. So if you all have any question, just send me an email on which question you want to ask, and then we'll do those examples or questions that you have on Thursday. Other than that, thank you so much and have a great day. I will still be online if you have any other questions. Okay.